If you told little kid Amelia, when you're in your 40s, your ceiling fan may not be able to talk to your smart light bulb, I would have had a bunch of questions. Starting undoubtedly with, my ceiling fan can talk? I don't know how many smart home devices you have in your home right now, but that number will most likely increase in the next couple of years. But getting those devices to communicate with each other, well, that's another problem entirely. And then here comes Matter to make that communication easier than ever before. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Charlie Ice and Hallie Vu from NXP and I chat about the benefits of the Matter ecosystem. We explore the networking protocols supported by Matter, how Wi Fi and Thread work together in the Matter ecosystem, and how you can leverage NXP solutions for your next Matter design. And before we get started, don't forget to click that link. There you can find even more information about this topic from NXP. Hi, Hallie. Thank you so much for joining me.
Hi, Amelia. Thanks for having us.
Absolutely. And hi, Charlie. Thank you for joining me.
Thank you, Amelia. I am thrilled to be here.
Fantastic. All right, Charlie. So we're talking about connecting the smart home with Matter, Wi Fi, and Thread today. But before we dig into the details, can you set the stage for us? We're looking at more and more connected home applications these days, right?
That's exactly right. And as you can see, as consumers start to adopt more smart home devices, the number of devices is going to just grow exponentially, both inside homes and inside buildings. So, smart ceiling fans, smart light switches, smart thermostats, the list just goes on and on. And today, most likely in a user's home, those smart home devices are all part of different closed ecosystems. So, the ceiling fan can't talk to the thermostat, and the doorbell can't talk to one of the indoor light bulbs because likely they're all on different ecosystems that are closed where those devices can't talk to each other. So, as you can imagine, once you start to get 10, 20, 30 smart home devices that are on separate little closed ecosystems, little kind of islands, if you will, it's really hard to automate the home and make it truly intelligent and autonomous because nothing can really talk to each other. And that's where Matter comes in. And we're going to talk about Matter today in more detail, but also some of the networking technologies like Thread and Wi Fi that are really going to make Matter what we think is going to be the end solution for an autonomous, intelligent smart home.
All right, Charlie, let's start with Matter. For my audience who may not know, tell me more about it.
So, Matter is at a high level designed to unify the smart home. The goal for Matter is to allow all the devices in the smart home to speak the same language so they can all interact. And Matter's led by the Connectivity Standards Alliance. This is a group of over 300 companies supported by some of the top brands in smart home, like NXP, of course, but also Apple, Amazon, Google. You can see a list of brands here on the slide that are really helping define the standard and evolve the standard and make it even more applicable as smart home devices evolve. And at a high level, the way Matter works is it defines device types. And so a manufacturer will pick the device type for their end product. So let's say it's a light bulb. The Matter light bulb has a set of attributes defined by its device type. So let's say on, off, and dimming, and color. A Matter light switch, it would be a device type with its own set of things that can interact and operate with. And the light switch would tell the light bulb to turn on. And because they both use the common Matter device types, the light switch knows how to tell the light bulb to turn on or turn off or to dim because they're all using those common device types. And that's also what allows Matter devices to operate within some of these bigger smart home ecosystems, like, say, for example, Apple HomeKit. Matter devices can connect right into the Apple HomeKit ecosystem because the HomeKit ecosystem supports Matter. Same thing with Alexa. So a Matter device can operate within multiple different home ecosystems that support Matter without the end user having to worry about, does it really support that ecosystem or not? If that Matter logo is on the box, on the device, that device can work within any smart home ecosystem that supports Matter as a protocol. And so that's really what the power of Matter is, that it allows devices not only to interact, but it allows device manufacturers to get one certification, Matter, designed for one protocol, Matter, and then they can have their device be used in any smart home ecosystem that supports Matter. And as you can see from the slide, today there's quite a few. In particular, Amazon, Apple, and Samsung and Google all have support for Matter within their smart home ecosystems.
So, Charlie, what networking protocols are supported by Matter?
That's a great question, and one that we get quite often. And it's really important to understand how Matter is set up to answer that question. And so, Matter is an application layer protocol. And what that means is it's not actually doing any of the lower level networking. Matter runs on top of any networking protocol that supports IPv6. So, like you and I are talking English right now, and that's kind of like Matter. Matter doesn't care what the transport medium is. In this case, it's computer audio through Zoom, or it could have just as easily been a old school landline. Matter is the same way. Matter doesn't care what it's talking over as long as that thing is IPv6. And so that means today we have three transport options for Matter, and that means Ethernet, Wi-Fi, and Thread. Those are the three that Matter supports. As new IPv6 networking protocols come out, Matter could certainly support those as well if they support IPv6. Now, another good question that comes up quite often is what about Bluetooth? Bluetooth is used in virtually every device in the world that has wireless. How does Bluetooth fit into Matter? And the way Bluetooth fits into Matter is it's used just for device commissioning. So you scan a QR code and the device is able to talk to the smart home or to the smartphone through Bluetooth and set up all the credentials, all the security pieces, and then it hands it over to the Matter network, such as Thread or Wi-Fi, and then turns off Bluetooth. So Bluetooth isn't used for any kind of Matter data transferring or command protocols. It's really just designed to get the device onto that network that Matter is using and the Matter, what we call fabric itself.
So, Charlie, is Matter the network?
Kind of. And the reason I say that is Matter is composed of multiple networks, Ethernet, Wi-Fi, and Thread. And then Matter itself is actually called a fabric. And the reason they say that is because there's underlying networks beneath Matter. And we'll show a diagram in a minute that'll help this make more sense. But a Matter fabric is a collection of devices that share common security credentials so they can all communicate with one another over the Matter protocol. And then that fabric sits on top of different networks. And so your home might have one Matter fabric, and then it would have a Wi-Fi network that's part of that Matter fabric, and a Thread network of devices that are also part of that Matter fabric. Does that make a little bit of sense?
Oh, it sure does. So, Charlie, talk to me about Thread and the Wi Fi networks a bit as well.
So, one of the things that's really exciting about Matter is it's opening the door to unifying different networking technologies within the home. And I'm sure all of your listeners are very familiar with Wi Fi. It's in virtually every house and every building. And Wi Fi is great. It's a star network configuration. So there's a central router that connects to each device. And it's really good for wall powered devices, things like a smart plug or a light bulb, or even things that need higher data rates like video doorbells. So that's where Wi Fi really shines. Where Wi Fi has some downsides is it's not super, super low power. And so one of the newer networking technologies that's really starting to gain traction within the smart home is called Thread. And Thread is a very low data rate, low power mesh networking technology. And because it's a mesh, the more devices you have in the house that are Thread, the better the network is, the stronger the network is, and the longer that network can reach. So you can get excellent coverage in your home by having more Thread devices because they're all part of a mesh. And if one drops out, the network can self-heal and recover from that. It's also been architected from the ground up to be ultra low power. And so that means that for devices that might not need to send a lot of data, but need to last years and years on a battery, like say a glass sensor or a door or window sensor or just a temperature sensor, Thread's a great choice. And it really brings those devices new capabilities because they can last on a single battery for a much longer time than they would on a Wi-Fi network. And so through Matter, these two networking technologies can really be brought together in the home and let the user pick the best technology for the device type that they're putting into their home, be that Wi-Fi or Thread.
So, Hallie, how do Wi Fi and Thread work together in the Matter ecosystem? How do they connect the Matter ecosystem?
Well, Wi Fi and Thread work together by connecting the different nodes of the Matter ecosystem. So here we can define some of those nodes. Starting with the Wi Fi or Ethernet nodes, these are the devices that are connected to Matter via Wi Fi. And this could be anything in your smart home that is connected to your Wi Fi router or plugged into the Ethernet. And then connected to both Wi Fi and Thread is the Thread border router. And you can sort of think of this as where Wi Fi and Thread meet. The border router connects to all of the devices in the Wi Fi network as well as all of the devices in the Thread network. And this sort of meeting place is what allows your home Wi Fi network to communicate to all of your Thread enabled devices. And those Thread enabled devices that are connected to the border router would be your Thread routing nodes and your Thread end nodes. The routing nodes are usually wall power devices that can extend the Thread mesh by serving as a connection point between the border router and the end nodes, which are typically the battery operated, more power sensitive devices in the home. And so, expanding on this, here we can see that smart home Matter ecosystem with all of those different nodes that we just defined now shown as multiple devices with shared security credentials that are all interconnected in the Matter fabric. So, starting again with the Wi Fi edge nodes, these could be devices like your phone or your computer or your home surveillance system, all of these things that are connected to the Wi Fi. And then connected to the Wi Fi and Thread are the Thread border routers. And some examples could be a smart home control panel or a smart plug or one of those smart speaker home hubs. And then we have the rest of the Thread network, which is made up of the Thread routing nodes and the Thread end devices. And so those routing nodes are the wall power devices, such as the lights or the light switch. And the end devices are the battery operated devices, such as the door lock or sensors or window coverings. So we can see that Wi Fi star network configuration that was mentioned earlier. And this relies on every Wi Fi device being connected to the Wi Fi router. And we can also see that Thread mesh network that was also mentioned with the Thread devices all connecting directly to each other. Now, we can actually weave through these networks, through the nodes of this Matter fabric, and see how a Thread end device can communicate with other nodes in the ecosystem. So let's say the smart door lock has some tamper detection, and this information can be relayed through the multiple networks from the door to a smart light bulb, to the control panel, to the Wi Fi router, to you on your phone, telling you that there is someone detected at your door. And through the Wi Fi connection on your phone, you can check the home surveillance system from an app, for example. Or let's look at another sort of pathway here and say that the temperature sensor detects that it's abnormally cold in the house. And this information can be relayed through the multiple networks, just like the door and the smart surveillance system that we just saw. In this case, it would go from the sensor to the smart light bulb to the home control panel to the Wi Fi router back to you on your phone, telling you that the temperature has suddenly dropped. And through the Wi Fi connection on your phone, you are able to adjust the temperature on the control panel and turn on the heater. And so these are just some ways that the Matter ecosystem can make our homes smarter and more connected.
Hallie, how can we build this Matter enabled ecosystem using NXP solutions?
Well, NXP can provide a solution for the entire Matter ecosystem, from the Thread border router to those Thread end devices. And this can be done with the RW612 tri-radio wireless microcontroller and the MCX W71 multi-protocol wireless microcontroller. And these products are really better together when paired in the smart home application. So we can take this example for the smart home control panel. Here we see the RW612 presenting a single chip solution for the smart home controller, which acts as a Thread border router, connecting the Wi Fi network to the Thread network and enabling communication between the two. And the MCX W71 makes a good fit for the smart lights or the window coverings, any of those Thread devices which connect to the smart home controller and act as the Thread routing nodes or the Thread end nodes in the ecosystem.
So, Hallie, what makes the RW612 an optimal solution for the border router?
Well, the RW612 is a tri-radio wireless microcontroller. And so tri-radio referring to, in this case, Wi-Fi, Bluetooth, and 802.15.4, which itself is the basis for Thread, Zigbee, and Matter. And because of this tri-radio capability, the RW612 makes a great single chip border router as it's able to connect to both Wi-Fi and Thread. Beyond the wireless connectivity, this microcontroller also offers a dedicated core for application, a rich set of peripherals, and advanced security. And these features really optimize the RW612 for a wide variety of use cases in the smart home. And that control panel that we just looked at is a really good example, requiring high performance connectivity, plenty of IOs, extensive memory, and an LCD interface for that smart HMI.
So, Charlie, what makes the MCX W71 an optimal solution for the Thread devices?
Well, with the MCXW series, just like with RW612, we support multiple protocols, and we're really focused on Matter with Thread, although we also support Zigbee or Bluetooth. And the MCXW is designed to be a very low power MCU for Thread devices, but at the same time, provide lots of performance with a 96 megahertz Cortex M33 MCU core. We've also designed it with the idea of upgradability in mind. So it has its own dedicated radio subsystem, and that subsystem has its own flash, its own RAM, and its own core. And that means we're able to upgrade the radio to new versions of the standards as they evolve. Even when the device is deployed in the home, we can upgrade the radio to support new versions or to patch any security flaws that are found in the existing version of the wireless standard. So when Thread publishes a new version of Thread, we can upgrade our radio to support that new version of Thread through simple firmware updates. We also have really spent a lot of time thinking about how to make our device very secure. So just like with the RW612, the M6W series has an integrated edge-lock secure enclave. And this is NXP's security piece inside the MCU. It's built off of our decades of security experience and expertise, and it's its own separate, isolated system on the MCU, and it meets and even exceeds all the security requirements that Matter has, and sets our device up to be ready to meet future security regulations as they come out from various countries. And then the last piece about the M6W is it's part of the MCU Expresso developer experience. In fact, both of the devices, the RW612 and the M6W, are part of that, what we call the MCU Expresso developer experience. This really allows developers to achieve scale in their designs and also quickly prototype their application. So both RW612 and MCXW, as well as NXP's other MCX MCUs, all share a common SDK that we call the MCU Expresso SDK. They also all support VS Code for a premium, modern IDE experience. They also support other IDEs as well, such as MCU Expresso IDE and IIR. But the idea is with the MCU Expresso developer experience, developers can learn one SDK, they can learn one IDE, VS Code, for multiple NXP processors. So in the previous example, if you're developing a Thread border router with RW612, you can then take that same developer experience, if you will, the IDE, the SDK, the tools, and that translates directly onto M6W also. So you're not learning a whole new tool chain to do a design with a different NXP processor. It's the same tool chain. Both of these devices are supported by what we call the Application Code Hub. And this is a place where NXP hosts lots of different example software and demos for customers to use to get up and running quickly. So Hallie talked about the LCD display and driver on the RW612. We have a demo of that on the Application Code Hub that customers can go and download and use in their own end application. And then finally, we have done a lot of work to make hardware development much easier. And we have what we call freedom boards that are low-cost development tools. And then we also have the expansion board hub. And just like Application Code Hub is there for software, Expansion Board Hub is designed for hardware where customers can easily find add-on boards and they can search by their particular board that they're using and find the boards that will work on their development board for their end application.
Okay, so Hallie, how can developers get started designing for smart home using the RW612 and the MCX W71?
So you can get started today with NXP's latest wireless development Freedom boards, the Freedom RW612 and the Freedom MCX W71. And so, like Charlie mentioned, this Freedom platform is supported by the MCU Espresso developer experience. So application middleware from NXP and OpenSymsys packs enable easy software integration, and examples can be found in the NXP Application Code Hub. The Freedom boards can also be used with stackable expansion boards with standard pre-populated headers and compatible drivers that can be found on the NXP Expansion Board Hub. So this Freedom platform is really comprised of hardware and software. It's a great tool for getting started because it's got everything you need and is designed for quick and flexible prototyping on low-cost compact boards.
Fantastic. Well, Hallie and Charlie, I think that's all I have time for today. Thank you so much for joining me.
It was a pleasure, Amelia. Thanks so much.
Thank you, Amelia. It was fantastic to be here.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from NXP. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.